Hello and welcome to the third episode of Learn Angular from the Scratch. In this series, I am providing you step-by-step guidance to master the craft of Angular, and simultaneously we are making an awesome Angular e-commerce Angular application. In the previous two episodes, I have given you a detailed introduction of Angular, its benefits, folder structure, etc. So just in case if you are new to TypeScript, I have dedicated an entire 1-hour second episode to TypeScript basics for Angular. Please go check that out if you haven't done that yet. Today we'll build the login and sign up part of our application. By the end of this video, you'll have a clear idea on how to design a scalable Angular application, apply lazy loading to the Angular modules that improves the application load time performance, how to integrate and use Bootstrap 4 to style your application, hosting REST API with nodejs Express framework, creation of database and collections in MongoDB, authentication and encryption with jsonwebtokens and BCrypt package, and last but not the least, communication with any backend using HTTP services from Angular UI. So without wasting more time, let's get started. So I started by moving the app component and HTML and module files to a newly created core directory. Also, as you can see here, an IDM component is generated via CLI commands. From this root configuration, the login route works as expected, but blank paths shows a white screen. Let's fix this by adding, or I should say replacing, the component key with redirected to login. The path match tells the router to match the redirect route when the remaining URL begins with the redirect route's prefix path. In this case, that is login. Fine. So this was a simple routing example. Here the compiler is instantiating the login component on application load time. Now if you have sign up, reset password and other similar kind of component, their memory allocation will take place during the app load time, thereby impacting the load time performance heavily. So let's see how we can avoid this scenario. Let's generate an IDM module and its routing configuration file. Then copy the route configuration from app routing module to IDM routing. Now we'll generate a dedicated component for login under IDM folder. So this will be declared in the IDM module. So now our IDM module can sit inside the app module and we can discard the previously created IDM component. Now modify the app route file and replace component with load children to provide the entire IDM module to compiler when path is IDM, and thereby avoiding multiple unwanted component instantiation. During runtime, application will find this IDM routing module and allocate memory only for the component in demand. That is the login component in this case. This is what we call lazy loading. Let me show you the component tree here. Going forward, when we have other components like sign up, reset password, etc., this is how lazy loading helps to download single component during runtime. Now let's add some styles to the login component with the help of Bootstrap framework. To achieve it, visit getbootstrap.com and click download. Since we are using SAS preprocessor, download the compressed files from this download source button. So once it is downloaded, extract the content. Then go inside the extracted folder and find the folder named scss. Copy the entire content of it and navigate to assets to create a library folder for this. Now push the copied contents under Bootstrap folder. Here are the list of files provided by Bootstrap. This Bootstrap scss brings all of them together. Next, we need a barrel to expose all the style information to the Angular JSON. For that, we'll create an application scss file and import the Bootstrap scss file. Then open Angular JSON and add this file under styles array. Adding inject key with true value will exclude the bundle from injection. By adding a bundle name, we can name the bundle for the scss entry point file. Now that we have our design framework ready, we can start modifying our login template. This is going to be a simple Bootstrap sample form with div, container and row. Adding an article tag for a self-contained block. Better I copy the form body from the Bootstrap site only. Here it goes. So before going ahead, I forgot to create a dedicated folder for the SAS files. So that's what I'm fixing now. After that is sorted, to add custom styles, we're gonna create one more folder under assets directory called custom styles, and inside we are creating a main scss file that holds custom style for the entire project. Let us add this class to bring the login form to the center of the page. Of course, we need to update the scss entry point file application scss to make this happen. I think this looks better now. Going forward, we need a way to handle the form inputs. For that, let me create a model folder under IDM and generate IDM model.ts. For our application, we'll use model-driven approach with the help of reactive forms. Now this requires a little background knowledge. I recommend you to visit the Angular's official website to learn about reactive forms, or comment down below if you need a dedicated video on these topics here. Since our login form has only two controls, we are returning them from this getLogin model method along with the required validation, assuming both the fields are mandatory. To make use of this method, add this class as a provider inside IDM module. This way, single instance of this class will be available throughout this module. Now we are good to add this model as a dependency here. finally creating a container for the form group before attaching it to the template file. Here same container will be used as form group name. I'm adding proper form control names from the ITM model respectively. For debugging purpose, let me print the values of login form on the top. To use reactive forms in Angular, it is required to add reactive forms module under module imports of the corresponding module. I'll move this thing to the app module later. As you can see, form values are handled perfectly here on the fly. Now you might want to add a submit event handler as well. This only checks the validity of the form group variable and thereby updates a boolean field. Now let me add some validation message below the form controls. So this guy should look like an error message, hence a class is needed for the font red. Okay, the error message is coming fine now. Only the styling is to be added to the main SCSS. There you go. Let me adjust the class names a bit. Now along with the error message, we might want to highlight our input boxes as well. So for that, we'll dynamically add this class for each input box with similar condition. I think this is enough for our example. Now, what about the ones who are yet to sign up? There has to be a link like this right next to the login button. Alright, but this should take us to the next component, that is the registration component. But before that, let me create a service class for IDM component that takes care of utility tasks like navigation and we created this file using Angular CLI's generate service command. We need this behavior subject throughout the application to denote the state of the application. Now, subjects under RxJS library is a vast topic and requires deep background knowledge. Angular uses RxJS library as a state management tool. Now, exactly like IDM model, we are adding IDM service as a dependency to the IDM component in order to use its utility methods. Set logged in denotes user is logged into the app. In the upcoming episodes, we'll see more about it. Now we need an application-wide configuration service to handle common configuration issues. As of now, we just want to write our navigation logic centrally. For now, adding this directly to the providers array, but as application grows, these services should be moved to a different file. Going forward, we'll use this doNavigate method under app config service for page navigation. For this, we need router as a dependency. Alright, now that we have our app config ready, we simply add that here in our IDM service constructor to make use of its navigation service. This is exactly what we are going to do now. Simple. Just take the URL as an argument and pass it to the config services doNavigate again. Finally, now as our navigation logic is ready, we need to add a new route for the sign up purpose. Path can obviously be sign up only, and this should instantiate not login but registration component. Structurally, which is similar to the login component only. Creating registration component using the same CLI command used for login. Now, hopefully after all this, your link should take us to the test registration page. Now we'll quickly copy the content of login page and paste it to registration. I'll quickly make this registration component ready. We have already performed similar exercise for login, so I'm not gonna repeat myself again. Alright, so we have developed the login and registration component for our application. All we need is a backend to store the user data and authenticate the inputs. Express is a relatively lightweight nodejs framework. For our demo application, we'll use this framework for hosting our application backend. So let's jump in and add Express as a dependency to our application. Now let me create a new folder in our application root and name it server. Inside server, we need to have an entry point for our Express host. app.js is that entry point file. Here we'll start with regular imports. Let's put new Express application inside the app variable to start a new Express application. Routes are primarily there to maintain REST endpoints. We need some more imports. So CORS package to enable CORS or cross origin resource sharing with various options. And body parser extracts the incoming request stream and exposes it to the request argument. If we explicitly provide any port number, then app will use it, otherwise we'll use 3001. And this app use body parser JSON basically tells the system that you want to use JSON. Let's enable CORS requests. Extended option tells the system whether you want to use simple algorithm for shallow parsing or complex algorithm for deep parsing that can deal with nested objects as well. Before going ahead with the development, let's add this middleware dependencies to our application. Finally, add this app listen method. It basically returns an HTTP server object. Just console it now for the testing purpose. Express apps can use any database supported by Node. MongoDB is an open source NoSQL database that uses a document-oriented data model, and it fits beautifully with nodejs. However, MongoDB is optimized for fast single queries and small document sizes of 16 MB max. So if you are building file storing app and want to store users' large files, MongoDB probably is not the best choice for you. Let me install MongoDB Community Edition from the official website. Here I'm showing you step-by-step process. Compass is a GUI for MongoDB. You can keep this checked if you really want to use it. So it took quite some time for me to install the MongoDB. Anyways, now let's start the database server. Based on the installed software version, this folder name will change. It's 4.4. Nevertheless, process remains mostly same. Here you should see two executable files, one called MongoD and another is Mongo. I'm starting MongoDB daemon process. Simultaneously, Mongo is a command line shell that connects to MongoDaemon. Let me print the available database in the server. Now let me create and switch to our application database. Now we have our DB server ready. Let's configure our application for the same. It's very simple. By default, MongoDB listens for connections from clients on port 27017. Declare this UI constant first with the document DB name. To connect to the MongoDB database, we are going to use a module called mongoose. We are going to use the mongoose ODM to access our library data. Mongoose acts as a front end to MongoDB. We will need to install mongoose module just like we did for Express. Now let's design schema for the user collection. Each file under this model folder is like a table in terms of RDBMS. After defining the user schema, we have added it to mongoose in the last line. Okay, so this route file should be users.js, not index. Because in the upcoming episodes, we'll add here other routes for products, cart, etc. This should automatically update the imports in the app.js file as well. Yes. The DB connection call should happen here in app.js itself and not in the routes file. Let me add a couple of items here before we can start the app. Oh, I forgot to add the name field in the user collection. And it's a convention to add the creation date for each row. Of course, by default, it will store current timestamp. Now as you can see, we have our database ready and it's appearing in the list of available databases as well. Finally, I've got my REST endpoints ready for testing. So let me quickly describe you everything here. I'll explain you these two packages, BCrypt and JW as and when it required. I have imported the user schema definition file here. And now onwards, this user constant will be used to access and manipulate the user collection. From a traditional RDBMS point of view, this can be referred as a ORM object, though both are not same. I mean, kind of same. We have two REST APIs here, which accepts only post requests from the client side. One for creating new user and another for login verification. Since body parser has exposed the client-side request's body to the request argument, we can easily extract that info and store it to the user data constant. Before going ahead with the data insertion, it is important to check for existing rows to avoid adding duplicate data. Find one should return a data object if this email is already present inside our user collection. Then we'll stop the execution and return false status. Otherwise, when find one returns null, we are hashing the user password with the help of BCrypt's hash method. Ideally, we should generate a salt value and apply it in the second argument. But here, for simplicity, I have just added a random number. Now, if everything goes as per plan, it is time to insert the user data object into the database. Also, proper catch block is needed for each of these operations. Now let me open and show you my login method. Since this method mainly validates the user input, here we are checking for the unique row having the same combination of email and password as that of the user input. Same find one method is used for searching the email address. If the query returns a valid result set, we need to match the password from the result with the user input password. Compare sync under BCrypt package does that for us. Basically, we want to return a JSONwebtoken corresponding to the currently logged in user, so that subsequent API calls can be authenticated before processing. For that, we have prepared a payroll for the JWT input. Already kept a simple string for JWT secret key. Everything works as per plan. We should receive proper token every time we trigger this API. Otherwise, response status will be false with relevant error message. Hope all this makes sense now. Now let me test this API using Postman. Already I have done the setup here. So for existing user, registration API will throw this message. And as you can see, for new user, it successfully adds them to the database. Let us use the same credential for login API as well. Okay, now both are returning proper values and doing verification as per the logic provided. Let me test the same from the UI as well before I show you the actual mechanism. I am able to get a success response for login, as this credential is added to the database already. Same way, unauthorized inputs are not at all welcomed. Let's create a new user and see. I'll create an account for MSD, of course, because that's what is there in my mind currently. Okay, now the account should have created, and let me try to log in with the same ID. Perfect. In order to connect to backend services, first thing is to generate an environment JSON file and maintain the base URL for all the REST endpoints here. Since our Express server is listening to port number 3001, keep the same value here as base URL. Now this file should be consumed by our application config service and store the base URL as a config variable. Therefore, we declare this base URL field on top of the page with empty string. And this basic HTTP GET method returns an observable for the environment file. We'll see the usage of this HTTP options field and HTTP client dependency next. Here, we created two methods for the application-wide GET and POST calls. It requires two arguments, one for the endpoint name and other for the input body. Simple. For our application, we kept a basic HTTP options object that can manipulate the HTTP header. Here it indicates that the request body format is JSON. Instead, if it was application XML, it would indicate that the request body format is XML, not JSON. Only thing left is to use this makePost method to the IDM component and call the login service API. That's what we have done here. Login is the API endpoint name, and login form group basically contains the email ID and password information. As a response, we are expecting an observable that returns an object with status and message. Ideally, this should be kept in an interface, but for our demo purpose, we have explicitly written it here. The rest of the code is almost same. In the next episode, I'll be writing the logic to navigate to the product dashboard here in place of these alert messages. Same way, the registration API is also called and adjusted the rest of the logical portion. In the upcoming episode, I'll take it from the same state and proceed with the development. Alright, so if you've learned something new today in this video, please don't forget to like this video and comment down below.